Okay, good afternoon, everyone. This is James Pitcher here from ZN, and welcome to this afternoon's webinar, Timestamping Smart Ledgers. This is me, and this is the proposed agenda for the next half an hour or so. So I'm just going to spend a few brief minutes introducing the research program, and then hand over to Sam Carter, who is going to run through a summary of the timestamping report, and there will be an opportunity for you to ask questions online. You can just access on the top right hand side of your screen. You'll see 4 boxes. Just go to the one that says ask a question, and then you can type it in and we'll see it come up automatically. And we're going to run 2 or 3 just brief, hopefully engaging polls as we go through as well. Okay, so this webinar is going to be a summary of the report on timestamping smart ledgers that we issued in May. We are, as part of this program, catching up on the reports that have been issued this year by doing a series of webinars that are summarizing those reports throughout August and September. But from October onwards, we will be holding the webinar a week to 10 days after the launch of the event. So we've been catching up. You're very welcome to go to the Long Finance website and look at the previous webinars that have occurred over the last 4 or 5 weeks or so. You can see the full report at the Long Finance website, or you can read the report. There's an abbreviated web link for you there, and you see the front cover. For those of you not familiar with us and our structure, ZN is the City of London's leading commercial think tank, established in 1994. Long Finance is effectively the pro bono research arm of ZN, and this comprises 4 major research programs: distributed futures, which is what we're going to talk about today, financial center futures indexes, eternal coin, and metacommerce. So the Distributed Futures program, it actually evolved from a forum designed to share intelligence on fintech, regtech, and other interesting topics where disruptive technology meets finance. It's now an open source research program for smart ledgers and new technologies. And our research is structured around 4 key themes: societal, technological, economic, and political, and directed at the 4 outcomes that you can see there. Timestamping clearly falls under the technology and changing systems heading. The Distributed Futures Research Program is sponsored by the Cardano Foundation. The Cardano Foundation's mission is the promotion of the developments of new technologies and applications, especially in the fields of new, open, and decentralized software architectures. Here are some examples of the reports that we've, the other reports, I should say, that we've launched over the last few months. And you can see that we're actually trying to develop an identifiable brand, actually color coding depending on which of the 4 themes the reports fall under. So timestamping is blue. The political is green, economic red, and social is amber or yellow. This is quite small print, but it gives you an idea of the scope of the research. We have 4 or 5 more reports being launched this year. And as you can see, there's a wide range of smart ledger topics under each of the 4 themes that we are focusing on. And actually, since going to press on this slide, we've probably added about 4 or 5 more as well. So there's lots going on behind the scenes. Some of you may be familiar with the terminology. But with some cryptocurrencies in the news particularly, you're probably all aware of the underlying technology of blockchain, for example. We thought it would be useful just to provide some context in simple terms, in terms of how we get from a ledger, which was and still is a basic record of transactions, how that becomes distributed, mutually distributed, and so on. I'm not going to read all of this out. But the key, when you get to mutual distributed ledger technology, the key words here are the immutable record and the fact that they are stored in multiple locations. Blockchain, transaction database shared by all nodes participating in a system based on the Bitcoin protocol. There's obviously a lot more cryptocurrencies now than just Bitcoin. And smart ledger, the key, this is a mutual distributed ledger with embedded executable code. Those are really kind of key words in the whole smart ledger environment. This is a slide that actually we are updating at the moment. We've had this slide at ZN for many, many years, and it initially was just to highlight the potential opportunities covered by smart ledgers in general, our research in general as well. You'll notice that currency is just the first word on the list. So there are many documents, and there's been much focus on cryptocurrencies. There's a whole range of other areas where there are immense possibilities for smart ledgers in particular. One that I always find resonates with me is under public records, where it talks about land and property titles. Just think, as part of the conveyancing process, all of the various parties that are involved where there is data already existing and maintained. So buyer, seller, estate agent, mortgage providers, lawyers, arguably, and of course ultimately the land registry, so the government. All of the data in all of those areas is readily available, but of course, because of the inefficiencies or pre-blockchain or pre-smart ledger, it takes a lot of time and is very expensive to extract that data. So if there were a blockchain that could cover, for example, conveyancing, then this would obviously be really helpful for everyone. I'm going to hand over in a second to Sam Carter, who's going to take you through a summary of the report. But perhaps to help Sam, and also just to get you engaged to start off with, we're going to start off with a very quick poll. And that is simply, do you know what timestamping is? So please feel free, that should come up on your screen now. Please feel free to select yes, I have some idea, or no. Just give me a few seconds for that to come through. Okay, great. So it looks like one or two of you may be changing your mind or ticking, but it's approximately 70% saying yes. So that's really good news. So Sam is either now going to hopefully validate that for you, or maybe challenge it for you. I'm going to hand over to Sam to take us through the next few slides.
Thank you, James. This is a quick run through a talk which I gave in June to launch the report. Some bits taken out, some bits skated over. So we'll see how it goes. The full talk and the full report are, of course, available online. So we just asked you if you knew what timestamping was. My definition is that timestamping is an association of time and date with a document or a transaction. We're going to talk about that today in the light of the new developments in smart ledgers technology, and we're going to try and assess smart ledgers, whether they are be distributed or not, to assess their usefulness in time measurement and timekeeping generally. Here's a summary of what we're going to be talking about. To save time, I won't read out the summary, but we're going to start off with timekeeping basically and end up with smart ledgers and finance. So briefly, timekeeping, as it is practiced in society and in finance specifically, we have International Atomic Time. These are all French acronyms. They are not, the letters are different. International Atomic Time is the international average of all of the atomic clocks of all the physical laboratories and other institutions around the world. Each of those publishes a coordinated universal time. In the UK, that comes from the National Physical Laboratory. And then, of course, the standard more recently is GPS, which is a system which we all know well, which gives you your location on the planet and also the exact time from a series of orbiting satellites. The NPL at the moment broadcasts their UTC from Anthorn in Cumbria. There's a big radio network there. And that is accurate to within a millisecond of UTC. So a fairly, by today's standards, rough and ready time. GPS is accurate within 200 nanoseconds and is is used very much as, until recently, as the backbone of the financial system. There are concerns about the fact that it is actually completely owned and controlled by the American Air Force, who have the ability to shut it down for locations at any given time. So a lot of people are trying to think about ways around that. And NPL, the National Physical Laboratory, are now offering a direct fiber paid for link which they call NPL time TM, and that is extremely accurate to 100 nanoseconds. You'll notice that all of these times at the top of the slide, they're all offset from each other by up to 20 seconds. That's for interesting historical reasons, which you can read about in the report, but doesn't matter in practice. Once an institution has received the time from whichever provider they choose, they have to synchronize all the machines in the institution. So this is a typical map of how that might be done. It's done in a tree structure. So you have a series of timekeeping servers at the top that then spread the time down through increasing strata of servers in order that they can all be synchronized as fast as possible. This has to be done semi-regularly, as these computers obviously do not have atomic clocks on board, just ordinary quartz or chip-based clocks, and the time drifts. So how that time synchronization is done, since about 1985, the network time protocol was the industry standard. And that is simply a situation where a client asks the server for the time, and if the time taken to get to the server, to process the request, and to get back to the client are all known, then with a reasonable degree of accuracy, the client knows the time as recorded by the server. There are a number of assumptions, and with big networks, this doesn't work as accurately as you might like. In particular, because the path between the client and the server is not necessarily the same as the path between the server and the client. So one makes averaging assumptions which are not true. More recently, the industry standard is PTP, Precision Time Protocol, where a time request travels through the network through a series of what are called transparent clocks, where the request is actually adjusted as it passes through every single element of the network, so that it is always adjusted for the time it's taken within that element. And this can sync a network to nanosecond levels of accuracy. So with all that in mind, let's turn to timestamping. If you're a client and you would like to timestamp a document or a transaction, there are a number of ways to do that. There are protocols available for you to, there is an ANSI standard available for you to request the timestamp on a document or a transaction. And there are various reliable or semi-reliable ways of doing it. The first one is a central method where you have a timestamping authority. You simply submit your document and it returns a timestamp for that document and a code which is stored. This is fine for low security applications, but if an outsider or a hacker wanted to spoof the time, they could very easily interrupt that signal and send back an erroneous timestamp, which you would potentially not notice. So that has been adjusted slightly with a linked centralized version of the same thing, where you not only have a timestamp coming from your timestamping authority, but you're also aware of what the previous and the subsequent timestamp was that was issued by that timestamping authority, which makes it much more difficult for anyone to change the time so that your link in the chain is broken. That's using a kind of sequentiality idea, which is also interesting in the case of ledger technology, which we'll come back to. Then we have a distributed version. This is the kind of thing we're going to be talking about today. There are a number of ways of doing it, a number of papers of various ideas on the internet which you can find. Before we do that, we're just going to look at some of the requirements which we want a timestamping system to have in order to know whether we're actually coming up with a good answer. So the first thing it must be is comparable. Comparable means that if two timestamps are in the same domain, they should be able to be compared with each other so that we know absolutely what they mean in relation to each other. Timestamping is, after all, about working out which of two events happened before and which happened afterwards. So comparability is key. Universality they must be independent of the technology which applied them. You need a central, frequently synchronized universal clock. Traceable, this is very important from a MiFID or regulation point of view. A market participant has to demonstrate that their timestamp is traceable through all steps back to the UTC, and this can be more difficult than it sounds with broken network links or undocumented links. And finally, immunity. Each timestamp must be immune from interference by a third party and impossible to change after it's been applied. So thinking about timestamping within a system as opposed to timestamping across systems, and we get into this question of precision and accuracy, which is a question of measurement in science generally. This is a very well-known way of demonstrating the differences between precision and accuracy. Let's have a look first at the dartboard. So we have darts thrown at a dartboard here. If they're all hitting the bullseye, they're both precise and accurate. If they are all hitting in the same place of the dartboard, but they are not in the bullseye, then they're precise in that they're all in the same place, but they're not accurate in that they're nowhere near the bullseye. So they're precisely wrong. Accurate, they're all around the bullseye, but scattered, and neither precise nor accurate, they're nowhere near the bullseye and scattered as well. So you can see that precise time measurement, if we're only interested in precision, it doesn't necessarily have anything to do with the bullseye, with the true time. And precision is a measurement of the granularity and how close those time measurements are to each other. Precision is to do with internal consistency, and accuracy is to do with external. And it's useful to keep these distinctions in mind when trying to evaluate how good a timestamping system is. So looking at smart contracts now, or ledger technology generally, if we want to use a ledger to timestamp the instant of posting on that ledger, is this possible? Now, if we have two different nodes on our smart ledger, it's distributed simply between two nodes, there is no single time at which that transaction becomes official. It may arrive at the upper node first and then the lower node, and what's more, the nodes must then come to an agreement about when it arrived on the ledger officially, which may be sometime later. In the case of Bitcoin, for example, I believe it's up 10 minutes later that a transaction becomes official. So one must ask, is it possible then for a client to timestamp their own transaction and then submit it to the ledger, where at least it would be stored, which is illustrated here. So we have transaction A is timestamped and transaction B is timestamped, but thanks to latency in the network, which cannot be anticipated, transaction B sits on the ledger before transaction A. So the time of stamping has got nothing to do with the time of storage. Now, this sequentiality in the ledger is one of its key features, one of the key technologies that underlies it. And sequentiality is, of course, inherent to the nature of timekeeping. So it would be good to try and take advantage of that in whatever scheme we come up with. So this perhaps is no better than a database or other system if we use ledgers in this way. So considering smart ledgers according to the CUTI standards, comparable, this depends on two major factors, precision and accuracy. Are two times comparable with each other in the sense of agreeing with the same universal time, that's accuracy, and can they be distinguished from each other with sufficient granularity, that's precision. This very much depends on the clock that the ledger is attached to, which is the same as any timekeeping system, really. Any technical implementation faces that challenge. So I've scored that one with an average. With universality, if you're using one ledger and clients are simply submitting their requests for timestamping to that one ledger, then we can agree a standard within that one ledger. So that's good. Cross-ledger comparison is still an issue. One would have to have an agreement with other providers to make that possible. Traceable. The same argument applies to traceability. Distributed ledgers make traceability more difficult. There's an interesting question here if whether MiFID would accept a distributed ledger's notion of traceability as acceptable. Every node on the system has to be guaranteed traceable individually and then traceable on aggregate, all of them together. I don't know if the MiFID has a concept of traceable on aggregate? Probably not. Immunity then is the last one. This is, of course, the greatest advantage of the ledger technology. The super audit trail and the consensus model ensures that nobody can change a timestamp at any point. A quick detour into financial regulation. MiFID II, along with its more well-known goals, such as unbundling, moving OTC markets, and increasing focus on the buy side, also had perhaps something that's received less attention, higher levels of surveillance, which is where timestamping questions come in, to trading questions and other financial areas. They issued Article 50 as part of the MiFID II, which is to do with this area, and that sparked the creation of the standard RTS 25. That demands cross-market synchronization, precision, reconstructability of past events, and auditability of infrastructure. Auditability and reconstructability, great advantages of the smart ledger technology. Cross-market synchronization, perhaps more difficult. Precision, we have discussed. Granularity, I'll come back to that in a second. I would like to ask you to take part in another poll to do with financial regulation, as it's good to get a feeling for this. The poll is, are you affected by the MiFID II regulation to do with timestamping and surveillance? So the results are coming in. We've got a lot of don't knows, which is an interesting one. I think that probably speaks to the necessity of actually working out whether this is a problem for your business or not. We've got 25% no's and we've got 13% yeses. So that's very interesting. I think it's clear that this is a necessary topic to examine. So if we think about one of the well-known results of the MiFID II regulations, we've got high-frequency trading. The need for new timestamping regulations was driven by these challenges. There are a number of definitions of high-frequency trading. Informally, I think we all agree that high-frequency trading has to do with taking advantage of price differences using sheer speed by reaching the exchange as fast as possible. And in order to do that, reducing latency between the system and the exchange through various methods. The ESMA, the European authority, has some more stringent definitions, which are surprisingly easy to meet. At least 2 algorithmic trades per second in the same liquid instrument, or at least 4 messages per second across all instruments traded over a given venue, which means that most electronic trading is probably deemed high frequency most of the time. It's not particularly fast. Recently, the advantages possible, according to some people, through sheer speed have become less profitable. HFT trading volumes have dropped, but this definition ensures that much trading, even if it's considered slow and old-fashioned, will still meet the definition. So if we have a look at the MiFID regulations that concern this quick trading, if we have a look at that, this is the regulations for the trading venues, the exchanges. If we have a look at the second row there, sub 1 millisecond, you're allowed a maximum divergence from central time of 100 microseconds, and that's the accuracy, and the granularity of the timestamp has to be 1 microsecond or better. That's the precision. Same thing for trading participants. The first line, high frequency algorithmic trading, 100 microseconds divergence from central time, granularity or precision 1 microsecond or better. There is a question here to do with what events exactly are being stamped, which was brought up during the research that we did for this report. This is going to take quite some unpicking, I think. No one really knows whether they're being asked to stamp a trade when it arrives at the very outskirts of their system, when it arrives at a trader's desk, if that's considered to be the booking of the trade, or the decision made by the broker. No one quite knows when that exact time, down to the microsecond, is, whether he clicks the button or when it goes through to when it leaves the bank. So there's a lot of thought about what constitutes an event in this question, which didn't matter when you were dealing with seconds, but when you're dealing with microseconds, it's very important. So there's a few separate areas of finance which we can consider smart ledgers to be useful. And they pretty much go from in to out. So within an institution, you've got the internal record keeping, and I think this is definitely a place where the ledger would come in useful. You've got an internal system which be controlled. You know that the time is universal and consistent. You can use it in a standardized way, and it provides complete auditability and transparency for all departments within a firm. Moving outside the firm, reconciliation between firms of their data and trading activities, more difficult. You need to agree on standards. You need to agree on how to cope with distribution type problems, whether you should be using a central ledger or whether you should be comparing your own ledgers with each other. And then much more difficult potentially is the trading, particularly the high-speed trading. That has a lot of thought needs to go into that before smart ledgers or even simple distributed ledgers or even simple ledgers can be thought about. So here, I'm not going to read all of these questions. These are some things that came up. You can have a look at them yourself. I would just like to bring out the last one. What other sectors could benefit from having central timestamping, ignoring finance for the moment? One other, if you ignore the high speed question, which clouds the issue somewhat, there are a lot of different sectors that could benefit from having centralized inarguable timestamping. One of them being, currently we have an enormous demand for people to know where their food comes from, and timestamping something as it leaves the farm, goes to the distributor, every single step of the way, you would have an inarguable transparent ledger which the supermarkets could not affect, where every consumer would know exactly how long their food had been on the road and how fresh it was and what conditions it was raised in. So that's just an example of something that seems to be on people's minds and could possibly benefit. But we'd like to welcome some questions of your own on the system. So if anyone has any questions, please feel free to ask now. We'll just leave some time for them to come in, and we'll do our best to answer them. James recently did a presentation on geostamping, which is of course the other side of the coin for timestamping. It is definitely a related field. They could very easily, particularly when we think about how GPS deals with both time and space, any stamping logic could deal with time and space simultaneously, which could be a great record-keeping facility for smart ledgers to take advantage of. Okay, we don't have any questions. If you do have any, please send them in to DN and I'll get back to you. Oh, yes, sorry, I apologize. We do have one question. A bit unrelated, it says, but how would you timestamp food in a manner that allows the purchaser in a store to see the record? Well, yes, I thought you might pick me up on the technical details of that hand-waving explanation. I suspect you would have to have some kind of, well, currently you get those price scanners in stores, which people take around and scan barcodes and find out how much things cost. I don't know how they work. It could be something like that, but it would be no good for the supermarket itself just to label something and say this is where it came from. That's exactly what we're trying to get around. So potentially that could be something that would have to be looked up by the user on their own system or afterwards. Not a great answer, needs some thought possibly. But thank you, James. That's all from me, and I'll hand back to you.
Great, thank you very much, Sam. Hopefully the lack of questions there means that Sam gave a really good explanation of timestamping, so thanks very much indeed for that. I see there are one or two that are just starting to come in now. We've got your email addresses, so we between us will answer those questions. Thank you very much indeed. I'm just aware of the time. So just finally, we've got one very last, one brief poll, please, if you could just answer the question we're about to put to you in terms of the presentation itself, so that we can learn. And so we're going to put this out there now. Did the event meet your expectations? If you could just please say yes, largely, to some extent, or no now, that would be great. So there's just a few coming in now. Thank you very much. I'll share the results with you imminently. Okay, so it looks like Sam's done a good job. We've got 30% saying yes, it did. Thank you. 43% largely, 29% to some extent, and no one said no. So that's always good news. Thank you very much indeed. Just two last things in closing then, please. If you are able to provide any feedback, or if you have any questions maybe not related to timestamping specifically, there's my email address at the bottom of the screen there. Please do send me an email. I'd love to hear from you. And then finally, these slides and a recording of the webinar will be available on the Long Finance website very shortly indeed. So thank you again for everyone for your time. Thank you, Sam, as an author and a presenter today, and we hope to hear from you all in the near future. Thank you and goodbye.